Hey guys, welcome back. Today I'm just going to add one new type of related rates problem so you can spend most of today reviewing yesterday's. Okay, so here's the new one and it just has a small glitch. This is a very common type of problem. Okay, before we get started, remember with related rates, don't put any numbers on your picture if they are changing as time goes on. Only put the numbers on your picture if that thing is not changing. Like the ladder problem yesterday. The only number we put on that picture was the ladder itself because that wasn't moving. All right, so read this one to yourself slowly and see if you can figure out what I mean. I want you to label the picture with variables if that thing is changing and with numbers if it's not changing. So hit pause. Okay, so for this one, what's happening? This cone or cup, whatever, is filling with water. And very important to know is the shape of the water is the same as this cone itself. And that's true for all containers, okay? So inside this cone is another cone, and that's the actual water, okay? So what's changing and what isn't? Well, the cone itself, the cup or the container, whatever it is, it's a tank, I guess, whatever, it's more of a cup. The cup itself is not changing size, so that we're going to put numbers. It has a radius of 3 and a height of, what did it say? 4. That's the cone itself. That's not going to change. However, as this cup fills with water, the radius and the height of the water, that is changing. So I'm going to call those variables, the radius of the water, the height of the water. Those two things are changing as the water fills into the cup. All right, now here's the big idea for these problems, something that you need to know back from geometry, but you may have forgotten, and that is that the shape of the water is proportional to the cone itself. So here's what that means. Okay, big R is to little r as big H is to little h. Now I'm going to write that as a proportion. Big R is to little r as big H is to little h. The container is proportional to the shape of the water inside. They're both similar cones. Okay, that right there, that's the key. Understanding this, without this, you won't be able to solve this problem, okay? So big R is to little r, as big H is to little h. Then what you're going to do with this, cross multiply, 3 times H equals 4 times R. And you're going to either solve for H or R somewhere along the line, but you got to do the rest of the problem before you know which one you want to get by itself, okay? So that's what's new here. All right, now let's go back and solve this problem like we did yesterday. All right, we're talking about the volume of water and the clue that it's volume. Remember, units say a lot. It says cubic inches. That implies volume. So I need the formula for the volume of a cone. This is one you should know. Okay, volume equals 1/3 area of the base is pi r squared times height. Okay, now we want rates to be involved, so we want derivatives. Well, heads up, if we did a derivative right now, this right side would require a product rule because we have two variables. And that is possible. However, you'll find if you try to do it that way, you won't have enough information to solve the problem. So this is where this stuff comes in, okay? You're going to end up getting rid of one of those variables, either R or H. And then because you'll only have one variable over here, you won't need a product rule. So it all comes down to, do I want the R or the H? Well, that all comes down to the question. So let's write down which rates are given and which rates are asked for, and that will narrow down which variables we want to keep. Okay, so from the top, the water is flowing at a rate of 5 cubic inches. So that would mean dV dt is 5. Okay, I read along, blah, blah, blah. Find another rate somewhere in the problem. Do they give me another rate or do they ask for another rate? How fast? That's a rate. How fast is the water level rising? Water level rising. What variable are they asking for? They want to know how fast this is changing. So their question is, what is dH/dt? This is essential for knowing which variable to keep. I want to know dH/dt. They gave me dV/dt. So basically, these are the variables I want in this problem. I only want V's and H's. So I got to get rid of this R. So how am I going to get rid of the R? Come over here and use that proportion. Solve for R. Divide by 4 on both sides. And we get that R is equal to 3H over 4. Replace this R up here with 3H over 4 and simplify completely. I want you to hit pause and actually do this. Replace the R with 3H over 4 and simplify. Do not do a derivative yet. So this is just algebra right now. We haven't even done any calculus yet other than interpreting the word rate. So we have 1/3 pi R squared times H, and R is 3H over 4. Simplify further. That's 1/3 pi. Square both the top and the bottom. 3H times 3H would be 9H squared. 4 times 4 would be 16. Keep going. Multiply across the top and the bottom. Okay. If I multiply across, well, actually I can cross cancel. That makes my life a little easier. The 9 is on the top, the 3 is on the bottom, so cancel. Multiply across. On the numerator, I have a 3 pi h cubed all together. In the denominator, all I have is 16. This is my new volume equation, okay? Double check your math, make sure you did all that right. But notice you want it completely simplified. And what two variables do I have right now? I have H and I have V. And that's what I need in order to answer these questions. So let's go back over what we did so far. Very, very important was this initial proportion. The point of this proportion is it allows me to get rid of one of these two variables. How do I know which variable to get rid of? Your DTs, your rates over here tell you whether you're going to get rid of the R or the H. Get rid of the R or the H using that proportion. Simplify completely. However, did I answer the question? No, I haven't even done the derivative yet. So now I'm going to start like from scratch. This is where I'm going to start from that equation. And now I need to do the derivative of both sides. Okay, so I usually like to write it as another whole new problem because a lot of my students actually forget they've done all this math. They forget that they haven't done any calculus yet, and they start plugging in now. We need to get rates involved still, so we still need to actually do the derivative. So it's kind of like where we started yesterday. So now from the top, just like we did yesterday, I now need to get time involved. I need to do the rates, okay? The derivative of both sides. The derivative of V is dV dt. On the right side, this is a power rule because I only have one variable. So 3 times 3 is 9/16 pi h squared dH dt. Okay, and that's what we did yesterday. Now that we have time in the problem, now we fill in all of this moment in time. Okay, dV dt they gave us was 5. H at this moment, the height at this moment, the water is 2 inches deep. Square that, you get 4. dH dt was the question. How fast is the water rising? Okay, simplify a little bit. This 4 over 1. So the 4's cancel. 4 and 16, divide them both by 4. Okay, and get dH dt by itself. So I'm going to take the denominator, which is 4, multiply by 4 on both sides first. So now I have a 20. And then divide by 9 pi. And dH dt will equal 20 over 9 pi. And that's how fast the height is changing. So it's one linear dimension. So it's inches per second. Inches per second. Okay, so I would highly recommend you watch that entire problem again from scratch. But it's kind of like 3 sections, okay? First, you have to know that there's a proportion anytime you have something filling a container, okay? The container itself is proportional to the shape of the stuff inside. That's the first thing. Next, you write your volume equation, but don't do the derivative yet. And the reason you know that is the rates, what I call the DTs. Again, for this problem, they gave us dV dt was 5, but they asked for dH dt. That determined which variables to keep. So I needed V's and H's in the problem. So I used my proportion to rewrite it so that I only have V and H. Once you've rewritten it, now do the same thing you did yesterday. Take the derivative of both sides. Okay? So that's all I'm going to do that's new here. Good luck, guys. Good luck with your assignment. Bye.